So now we're jumping into Chapter 4, Section 1, and we're finally going to be getting into some of the actual pre-calc and the trig for this class. Now, to start off, we're going to spend some time talking about an angle measurement that you guys are familiar with, where I could say that these two rays are approximately 60 degrees, and we're going to talk about a new angle measurement that has that same measurement, but in a different language. So now we're going to say that those two rays, the angle between them is going to be pi over 3 radians. So we're still doing the same thing. We're still measuring the gap between these two lines. We're just going to introduce a new language for describing it. So the first thing we're going to talk about is how to convert from something called degrees, minutes, seconds form into a decimal form. So using decimals is fine for saying maybe you have 2.5 degrees. But sometimes the textbook or other assignments will use a different notation for those fractions of a degree. Specifically, they'll define a minute as 1/60th of a degree, and then a second would be 1/60th of a minute, which means in terms of the original degree, it's actually 1 in 3,600 of a minute. So this is another notation used for breaking down part of a degree when you need to have like that fraction in between them. So the process for converting from degrees, minutes, and seconds into degrees is to divide the number of minutes you have by 60. So if they say you have 10 minutes, just take that 10 number and divide it by 60. And then take the number of seconds you have and divide that value by 3,600. Again, that 3,600 comes from the fact that you're doing 1/60th of 1/60th of a degree. So the 60 times 60 makes 3,600. Then whatever decimals you get from that, you will add those values to the number of degrees, and you'll have an answer in terms of a decimal instead of using those symbols. To go the other way around, you're going to multiply the decimal by the conversion factor that there are 60 minutes in 1 degree. This is essentially the same as doing something like saying I have 4 feet and trying to convert it into inches. So you multiply by a conversion factor, which is some true statement that relates the two measurements together. In this case, that 1 degree is equal to 60 minutes. So then when you take the degree measurement and you multiply by 60 minutes over 1 degree, the degree symbols will cancel out, and you'll be left with something in terms of minutes. If there's still a decimal after you do that, then you're going to take whatever is left in the decimal place only the decimal part, and you're going to multiply again, this time by the fact that there are 60 seconds in 1 minute. So this is the same skill that you guys do in your chemistry class called stoichiometry. We're just converting units from one to the next. To demonstrate that real quick with an example you should be more familiar with, if you had something like 4 feet, and I want to convert this into inches, then what I do is I multiply by some fact that relates feet and inches. In this case, 1 foot is equal to 12 inches. And then what happens is the feet units cancel out, so you get 48 inches. Now, sometimes you'll have the 12 inches on top, sometimes you'll have the 12 inches at the bottom. It depends on which way you're converting. So your goal is just to always make the one unit cancel out. So since this one had feet in the numerator, because I can think of that as 4 feet over 1, for my conversion fact, I had to say that the 1 foot goes in the bottom, and that way the feet units cancel out. So here's our first example. We're going to take this angle measurement and we're going to change it into a decimal of degrees instead of using the minutes and the seconds. So the first piece we want to focus on is the minutes piece. And if you look back at what I gave you in the rules here, for converting into degrees, divide the number of minutes you have by 60. So I'm going to take that number 24, divide by 60, and that gives me 0.4. Then I'm going to take the number of seconds that I have, in this case 36, take the number of seconds you have and divide it by 3,600. So in this case I have 36 divided by 3,600, and that's going to give me 0.01. So I still have the 42 whole degrees, and then I have 0.41 for the decimal of a degree. I'm just adding the 0.4 and the 0.01. So add those two numbers together and attach them to your whole number of degrees. Now we're going to convert the other way around. So this time we have a degree measurement with a decimal form, and we're going to change this into degrees, minutes, and seconds. So again, I'm going to ignore the whole number part out front. We're just going to focus on the 0.425 here. So looking back at the rules I gave you guys, take whatever is in the decimal, just the decimal part, and multiply it by 60 minutes in 1 degree. So in this case, I have 0.425 times 60 minutes over 1 degree. So 0.425 times 60 gives you 25.5. Now that's 25.5 minutes. But you can see that I still have a decimal in there, which means that this must be able to get broken down even farther. So I'm going to look back at the rules I gave you guys. If there is still a decimal, then multiply that decimal by the next conversion factor, that there are 60 seconds in 1 minute. So the decimal that I still have is the 0.5. So I'm going to say 0.5, and that's minutes, times 60 seconds in 1 minute. So again, this is making some of the units cancel out. So the minute units will cancel, and then 0.5 times 60 is equal to 30 seconds. So my final answer is the 37 degrees, 25 minutes, which is what I got here, but I'm not including the decimal part because we broke that part down more, and 30 seconds. So that's our answer. It's just another way of expressing that we have 37 whole degrees and then part of another degree. 0.425 is the same as 25 minutes and 30 seconds. So we've talked about how to express a fraction of a degree. Now we're going to go on to our other way of measuring angles. And I mentioned this on one of the earlier slides. So instead of using degrees, we will often be measuring our angles in this class using something called a radian. So to define what a radian is, it's the measurement around the outside of a circle so that that length, A, is the exact same value as the radius of the circle. So a radian is whatever that length is to make it equal to the radius. Now what happens with a radian is if you kept measuring radians going around the circle, so then that would be about 1 more radian, and then that would be about 1 more radian, and then you notice it doesn't quite make a horizontal line going across there. It's got a small extra little bit of a decimal on it, and then you measure another radian, and another radian, and another radian, and then what actually happens is there's this leftover piece, so it turns out that all the way around you have 1, 2, 3, 4, 5, 6, and then it's about 0.28 of another radian, which is where the value of the circumference of a circle being equal to 2 pi comes from, because 2 times 3.14 is 6.28. So now you're seeing that that radian measurement is what's creating that circumference formula of 6.28 all the way around, or for going around once around the circle, it's going to be 3.14. So half the circumference of the circle is 3.14 because it's 3 and then a small decimal of another one of those pieces going around. So the important fact for relating degrees and radians is that 1 pi radian is equal to 180 degrees. So depending on which way you're converting, if you're going from degrees to radians, then you want to put the degree symbol on the bottom so that the degree symbols cancel. If you're going from radians to degrees, then you're going to multiply by 180 degrees over 1 pi radian, and that will make the radian units on the top and bottom cancel. So it's the same kind of stoichiometry we were just looking at, where if you're trying to change from inches to feet or from minutes to degrees, you have to set up the unit so that one unit cancels with the denominator of the fraction, and then the new one that you have on top will be the unit that you've converted to. So here are a couple questions where we already know what 90 degrees looks like. Now we just want to learn how to express that angle measurement in terms of radians. So I'm going to take that 90 degrees and I'm going to multiply it by 1 pi radian over 180 degrees. So doing that will make the degree symbols cancel out, and 90 over 180 is 1/2. So I'm going to have 1/2 pi, or pi over 2 radians. So now whenever you see the angle measurement pi over 2, I hope you'll picture that same right angle shape that you guys are used to seeing for 90 degrees. Let's do the same thing for 270 degrees. My conversion factor is that 1 pi radian is equal to 180 degrees. So when I multiply those, the degree symbols will cancel, and then you just have 27 divided by 18, which reduces to be 3 over 2. So you have 3 pi over 2 radians. Now we'll practice converting the other way around. So again, I'm still using those same rules, but now I'm going from radians to degrees. So the only thing that's going to be different is now I'm going to put the 180 degrees on top and the 1 pi radian on the bottom, because my goal is to make the radian units cancel. So pi over 3 times 180 degrees over 1 pi radian. So the radian units will cancel and the pi's are going to cancel. So you have 180 divided by 3, which is equal to 60 degrees. Same thing for the next one. 180 degrees on top, 1 pi radian on the bottom. So the pi symbols cancel. And then I have 180 divided by 3 is the 60 that we just looked at. And 60 times -5 is -300 degrees. So we'll talk about the meaning of a negative angle measurement in a bit. That'll come up in a later section. It's just indicating which direction we're measuring the angle. So positive angle measurements, we're going to be measuring counterclockwise, and negative angle measurements would go clockwise. So here's a real quick word problem. You'll often see bearings for a plane or a boat or something indicated. In this case, we're saying that we have somebody flying due north, and he actually needs to turn and face northeast. So we need to figure out how many degrees he should be turning the bat wing. So what you want to remember for questions like this is that we're still talking about like an X and Y axis essentially. And if you're going from north to northeast, it's exactly halfway between the north and the east line. So it's cutting what's normally a 90-degree angle into two 45-degree angle pieces. So the number of degrees that he needs to turn the bat wing going from due north to northeast is going to be 45 degrees in that direction. The bearing for that would often be denoted as 45 degrees east of north, because he's starting off going north and then he's turning in the direction of east. The last formula we're going to talk about today deals with the arc length of a circle. So the formula is that the arc length is equal to the radius of the circle times the measurement of the central angle in the circle. So let's draw a circle real quick for reference. I'm referring to having an angle on the inside, and that angle measurement is theta. The length of either of these lines, because both of them go from the center of the circle to the side, that length is of course the radius, and then the distance going around the outside of that. So for the arc that we just drew, that length is what we call S. So we have S is the arc length around the outside of the circle, R is the radius of the circle, and theta is the central angle. For these questions, you just want to make sure that you plug the correct numbers into the right spots and then solve for what's ever missing. Don't make the mistake of always multiplying the two numbers they give you. They're not always going to give you the radius and the central angle of the circle. This example is asking for the arc length, so I'm just going to set up that S equals, now the radius is 2.5, but I'm going to express that as the fraction 5/2 times the angle of pi over 4, and if you multiply those two together, you're going to have 5 pi over 8. If you did that as a decimal, it'd be approximately